Okay, what I have here is about 2 feet of type K extension grade thermocouple wire, solid, and I'm going to straighten it out as we've discussed in class. This wire is quite stiff. So I need to remove the sheath and the individual wire insulation. See if I can do this without hurting myself. Here I will remove the insulation from the yellow marker. And this will take care of or get rid of or expose a section of the red marker. And now we'll take this pair and twist them together, and this will form one of the two thermocouple junctions that we need to make this work. There's the first one. So we're started. We'll need a second junction, and we'll need an opening for a voltmeter. So here's our thermocouple extension wire with both ends twisted. Nothing fabulous about it. The twisted pairs should be mechanically sound. And you probably never want to just simply use a twisted pair for a permanent installation. Welding is better. Okay, in order for this to be of any use to us, we need to have a place to put a measuring device. So we'll make an opening for a voltmeter. I'm going to mark one side of this thermocouple extension wire pair. Okay, I'm taking care so that I only cut one wire. Okay, so I've got the one wire cut, and now I want to split the sheath so that I can have access to two ends of a single wire at the point I will place a meter. You can see this stiff wire dangling around as I try to cut it. Okay, I've got it separated. Okay, you can see that the red lead is intact, and I've opened the yellow lead. Okay, here I've got, on the left side, I've got the tip of the thermocouple wire exposed to ambient temperature. And you see the red and black connectors. That is where I have inserted a voltmeter into the loop. And the styrofoam cup holds water with ice. So we can anticipate that the temperature of that liquid will be very close to 32 degrees Fahrenheit. And that will disable any temperature sensing or millivolt generation from that junction. So what we have here is a working thermocouple. All right, here the thermocouple tip is sensing the ambient temperature of the room. Now I have grasped the tip between my fingertips, and you can see the millivoltage increasing due to the change in its temperature that I have imparted with my fingers. All right, I'll let it go, and we should see it dropping back here. It'll be very slow, but it will eventually get back to its original voltage. All right, okay, I have dipped both ends into ice, and the next thing I'm going to do is I'm going to heat up the tip with a butane lighter. Okay, butane lighter. You can see a drastic change in the millivoltage. Okay, and I think we can all agree that a butane lighter is hot, and that's exactly what this thermocouple is showing us. So it's coming back down to ambient temperature, okay? And remember, the heat that we put into the metal, okay, has to work its way out by conduction and by convection. And so we've shown that a thermocouple can detect low temperatures and minute changes, and it can also detect very high temperatures.